you come up and do the recording, but I want you to direct kind of how we solve this. So what's the first step you take in method of joints?
We first solved for joint G.
Okay, so you just dove right in.
Yep.
All right, so you could solve for reaction forces, right? That's what I encouraged you guys to do first, is always solve for reaction forces. But in problems like this, the group says, hey, look at joint D. I have a load and two unknowns, so I can just jump right in and go to work, right? Comes from having done them enough. Okay, so he says, cool, let's do joint D. At joint D, I assume you have something that looks like this, where you have FDE and FCD. Is that right?
And one more.
And 8 kilonewtons. Thank you. Right? Having a good free body diagram would help. Okay, so I need to sum my forces in the X. So it looks to me like I'm going to have negative FDE. And let's see, this is 1, this is 2, so this is root 5.
Yep.
So that's going to be in the X direction 1 over root 5 plus negative FCD equals 0, right? Because FCD is going in the negative direction. Did you sum the forces in the Y then?
Yep.
So if we sum the forces in the Y, you had negative 8. What else did you have, Max? Minus 2 root 5. I think, yeah, plus 2 root 5 FED. And that has to equal 0, right? So we can solve that one right away. And what do you get for FED? 8.49 kilonewtons. 9.4. What group were you in?
I heard him say it the right way.
Oh, okay. You're the group that listens. FED, FCD. What'd you get? 4. 4 kilonewtons, and that's in compression. Okay? Then where'd you go from there? Ah, interesting. So at joint C, did you do analysis? Right. At joint C, we don't really need to do any analysis because we look and we say, hey, zero force member right here. How'd you know that, Jordan?
Because FCD and FBC cancel each other out, but there's nothing to cancel out FCD.
Right.
So it has to be 0.
So this is our second case for a zero force member, which is when you have a joint consisting of 3 members, 2 of which are collinear and the third is not. The third is the zero force member. So in that case, then FCD tells us what FCB must be. Must also be 4 kilonewtons in compression. Okay. Is this member not needed? The zero force member? Oh, it's totally needed. Why is it needed, Vlad? For support, because this is pushing this way. So as soon as I bump it at all, it would collapse, right? So we totally need that. All right. So where did you guys go next? Joint E. Okay, so then you come up here, and we're going to know at joint E, when we draw that free body diagram, we found FDE to be in tension, so we know that we draw it pulling away at 8.94 kilonewtons. We know that joint or force FEC is 0, so I'm going to leave it off, and I'm going to draw FEB like that, EB, woo, and FEF. And Jordan says, well, EB has to be in compression, which, okay, that's probably true, right? Because we know that 8.94 is pulling down, and this is the only thing that could push up, so it's going to. But I still drew it in tension, and I'm going to let my sign tell me that it's in compression, because that's how I roll. If you have a different way, that's fine, okay? So now when I do some of the forces in the X must equal 0, I will have, oh gosh, 1 root 5 times 8.94 minus FEF minus, ooh, this is 2 over root 8, okay. 2 over root 8 FEB. That has to equal 0. Sum of the forces in the y equals 0, up being positive. Let's see, here's my free body diagram. Right now I have negative 2 over root 5, 8.94, minus 2 over root 8, FEB equals 0. And what were you able to find for FEB?
11.3 compression.
Okay, and FEF?
12.
Okay. Continue bouncing through, right? Is that how you solved it?
Yeah,
Okay.
what's the B?
So then you went to B, right here, B. We know CB, we know EB, so we're just left with BF and BA, right? And then that allows us to jump up to F or to A, either one, and we're done with the problem, okay? So if I were to solve this problem using method of sections, yeah, Nate?
We decided on F first just because at A you have AX, AY, and
Sure.
F.
Yep.
FAF, so.
Yep. So let's say you got this problem on an exam and I didn't tell you to solve this via method of joints and I asked you to find the load in member BE. The very fastest way to do that would be to say, cool, boom, I cut it, right? Now, my truss looks like this. Now, some people were like, well, does it matter where you cut it? No, because what happens is that these forces, it's the line of action of these forces that you're going to care about when you sum the moments. So this is FCB, this is FBE, and this is FEF, right? And I know that I have 8 kilonewtons acting down here. And so in order to find this guy, I just say, okay, well, let's sum the forces in the x direction and say they're equal to 0. So what's acting in the x? Well, all my unknowns, right? And all in the negative direction. So I'll have negative FCB, negative FEF, and negative 2 root 8 FBE, right? And all that has to be 0. 3 unknowns, no help there. Sum of the forces in the y has to be equal to 0. This one's going to be helpful because I have negative 2 root 8 FBE minus 8 kilonewtons equals 0. So I can solve it right here and say FBE, well, I sure hope that it's 11.3 in compression, right? Because if I take the 8 to the other side, it would leave it as a negative value, and then I would multiply 8 by root 8 and divide it by 2. So I'd have 4 root 8, and what does 4 root 8 equal? 11.3,
Yep.
right? Okay? Much more direct to use method of sections on that problem if you're asked for this. Everybody feel okay about what happened, what just happened? Okay?
So basically you focus on the forces that go in and out.
So yeah, Natasha's asking, in method of sections, do you focus just on the forces going out? Yes, and this is going to become more important as we go on, that when you cut anything in engineering, you expose forces, and you expose internal forces. So when we cut the truss here, we have to account for the fact that there are forces that those members were holding. And so we put them on here as unknowns. Yeah, Rebecca?
When you had asked us to solve the problems we're working on with the method of, or the cut method, then we have to do both sides to find all of the numbers?
So Rebecca's asking, when we do something like method of sections, do we have to solve both sides, like look at this half and then look at the half over here to get the numbers? And the answer depends on what you're looking for, right? So no, cut it where you only have to solve for one side. So in this case, I was looking for member BE, and so I cut it right there so that I cut through member EB, and I only cut through 3 total. And then I can look just at this side, so I don't even have to solve for reactions.
Yeah, but if the problem's just asking for each member, then you would have to do both.
Oh, well, so if the problem was, actually, no, if the problem was, the question is, if the problem was asking for each member, would you have to do both? You couldn't do it for, if we cut it here and then analyze the other side, we'd get the exact same values. We'd get FEB, FEF, and FVC. Right? So this is only, the method of sections is only useful when you're cutting, when you're looking for something in the middle and not the whole enchilada. If you need the whole enchilada, you got to go method of joints. Okay? Yep. All right. Let's see if we can get through one more before we're done. There was lots of consternation about, oh, I didn't, that's right. Let's do your guys', Travis. So 611, I realize in my picture I neglected to put any loads on it, because right now everything's a zero force member. Where are the loads?
Yes. For C, it was 10 kilonewtons. Same with E. And then D is 20 kilonewtons.
This is 611.
This is 611.
And then
What are the measurements?
all the measurements horizontally are 2 meters.
2?
Yeah, between each little chunk.
Okay.
And then all the measurements vertically between each chunk are 2 meters.
Like that?
Yeah.
Perfect.
And so then this is 2, 4, 6, 8, 10, 12.
Yeah.
Okay. All right, so where did you guys start?
Started with all the reaction forces.
All right, so you started with the reaction forces. Is there a place you could start here on method of joints without solving for the reactions?
So you told us to always solve it first for the reactions.
I did.
Are you changing it?
I'm not changing it. I'm saying if you can see a way to do it without it, I'll let you. But I'm going to encourage you, because lots of people would look at this and they'd be like, oh, I'm going to try starting at this joint. And it's like, well, you can't. So just solve for the reactions.
Yeah, so we just started with.
All right. Victoria feels like I'm cheating her. And I'm not. Okay, so you solve for the reactions. Okay, so you're going to say that there's some AY and some AX and some GY, right? So when you do this, did you kind of just look at it and go, oh, AX is 0, right? So this should be something that you do enough of them, you look at this and you say, oh, AX has to be 0, okay? So then we can say, well, let's sum the forces in the y direction and set that equal to 0. AY looks like minus 40 kilonewtons plus GY equals 0. What else could you do? You could look at this and say it's completely symmetrical, right? So really these two 10 kilonewtons, the moments they produce would cancel out if we put them in the middle. So you have 40 kilonewtons going down. So you could just look at it and say, oh, GY is 20 and AY is 20, right? If you've done enough problems that you're comfortable doing that. If you haven't, then go through and show yourself that that's true, okay? But for now, I'm going to say, yeah, 20 and 20, okay? And now, what joint did you start at, A?
Yep.
That's the way to be. Start at the beginning, okay? So you've got 20 up, and then you've got F, A sub L, and F, A sub B.
Yep.
And we'll sum the forces in the x direction. Those have to be 0. So what do we know about one of these?
We know that FAB is in the x direction.
Yeah, but what do we know about the compression versus tension? One of them has to be compression, right?
Mm-hmm.
So we're going to have, let's see, F, A, L times 2 over root 5?
2 root 8.
2 root 8, yeah. plus FAB equals 0. And we'll have some of the forces in the y is equal to 0, which would be up 20 kilonewtons plus 2 root 8 FAL, and that would be equal to 0. So we can solve for FAL, which allows us to solve for FAB. What'd you get for those?
For FAB, we got 20 kilonewtons in tension and 28.3 kilonewtons in compression for FAL.
Was it 28.3?
28.3 compression.
Kilonewtons and compression. Okay. And where did you go from there?
Then we look at B.
Okay, so if you look at B, I'm pretty sure you
Zero force
solved for
members.
them, but if you looked at it, you could see, and maybe even before you dove into this one, we should identify where are zero force members. And I would say there's a zero force member, right? Because this is our second case, a joint with 3 joints, 2 of which are collinear, no load applied. The non-collinear one is a zero force member. And I'd come over here and say, well, this one looks kind of the same. Like this problem might be symmetric, okay? If I did that and I looked at joint L, I'd see, hey, this has to be a zero force member too, because at joint L, if this one's gone, that leaves this one, so then it's just 3 members, and that one becomes a zero force member. So this is 0 as well. Now, can I do that same thing with these? No, right? Because there's a load down here. But what that allows me to do is it eliminates analysis at 2 joints, B and L. Because now I know that FAB is also equal to FBC, and FAL is also equal to FLK. Right? Can you see what I did there? No?
Does make sense.
Okay. If these are zero force members, I could really redraw this truss and it would be the same. Just going to draw the end of it here, where this is A, L, B, K, and C, right? Because the dotted ones we decided are zero force members, right? So in that case, whatever the force is in AL must be what it is in LK. And same thing with AB and BC. All right? So we just saved ourselves 4 equations by identifying those as zero force members. So did you move to K or C next?
Next we move to C.
Okay, so at C, you have 10 kilonewtons going down, and you have AB, which is 20 kilonewtons in tension. And you're going to have some FCK and FCD, right? Okay, this one we can do by inspection, right? FCD equals 20 kilonewtons. FCK equals 10 kilonewtons. Both of those are in tension. How did I do that?
Equal and opposite.
They're equal and opposite, and I do the sum of the forces in X and Y in my head, right? Because I look and I say I've got 20 kilonewtons to the left. What can counteract it? Only FCD, which is purely to the right, so it has to be 20 kilonewtons, right? Everybody see that? Okay. So let's move then. Did you go to K or D next?
We looked at D, but realized we needed to.
Uh-huh. So if you look at D, you would know
Just scroll
FCD, but you'd have 1, 2, 3, 4 unknowns. So that's going to be a no-go. Let's go up to K. So at K, we'll have LK, which we said was compression, right? So I'm going to go ahead and draw it pushing on it. And I'm going to draw FCK, we said was in tension, so I'm going to draw it pulling on it with 10 kilonewtons. And then I'm left with FKD and FKJ. Alright, so this is kind of what I came up with for my free body diagram. sum the forces in the x, set that equal to 0. Looks like I'll have 28.3 times 2 over root 8. Is that right?
We just moved the paper.
I just moved the paper.
We angled it.
Oh, look at you guys. Huh? Look at that. They just twisted their paper and made it horizontal. That's tricky. Okay.
No, it's just 28.3.
So, yeah, so,
Yeah. We just said that.
huh?
It's just 28.3. It's not multiplied by anything.
Well, yeah, if you rotate the paper, yeah. So I'm going to say the x direction is now up and to the right, okay? So if I rotate my paper and make it so that it's horizontal, we can see that in the x direction, I'm going to have 28.3 plus fkj, because it's entirely in the horizontal. Then it looks like I'll have minus 10 kilonewtons times, oh gosh.
I think it's a different triangle. We initially thought it was the 4 over root 32, but then the new triangle is it's a 2 for root 20 triangle.
Yeah.
The old classic.
Yeah, so I'm not sure that I would have rotated this one. Because if you didn't rotate it, I agree there's more goobers in it, but check this
So
out.
we can leave as the 432.
Some of the forces in the x, I'm going to go back to saying it's horizontal, and it'd be 28.3 times, we decided it was 2 over root 8, right?
Yes. Yes.
Okay. And then you'd have plus fkj times 2 over root 8, excuse me. And in the x, then 10 kilonewtons doesn't do anything, and you just need fkd, which fkd, if we go over here, this is legs 4, that legs 2. So then it would be, in the x direction, 2 over root 20. So plus fkd times 2 over root 20 equals 0. And in the y direction, we'll have 28.3 times 2 root 8 plus fkj 2 root 8 minus 10 minus fkd times 4 over root 20 equals 0. So it's actually 6 of one, half a dozen of another, I think. Right? Did you solve these?
I mean, we solved it our way,
And what'd you get for fkj and fkd?
but our way was possibly wrong, so.
No, it wasn't wrong. It was just different. What'd you get?
So we analyzed a little bit differently after talking about it, and we got, for FKJ, we got negative 23.8 tension, so 23.8 compression.
Mm-hmm.
And then for FKD, 8.9 tension.
Okay. So this is positive, so it's
So that was
tension.
by doing our rotated
So this would be
method,
compression.
seeing the
Yeah.
triangle.
Okay, so that's if you did the rotated method. So probably we'll put a star by these and say we think all things being equal, these should add up. All right? Now, going back to the beginning of this problem, we could then move from K, we could move to J, right? And from J, we could move down to D, and then we could start bouncing our way through. Or we could, again, look at the problem and say it's symmetrical, right? This would definitely be a problem that if I asked you, hey, tell me what the load in this is, you would say, no problem, and slice it. Okay, because it's going to go so much faster that way. Rebecca, you got a question?
I was just gonna say, if you recognized that it was symmetrical, then would you just stop after you did J and D?
Yes, if you recognized that it was symmetrical, you would just stop after you did J and D and label these values. Okay? All right? So, we went through two together. So I apologize to Travis's group and Nathan's group that they only got to do 2 problems today. But the rest of you should have gotten to do 3. right? Because you did your own, and then you got to see these two as well. Okay? So please, I'm begging you. I have no problem begging and groveling. Please do some of these. You need to practice these. All right? And read section 6.6, excuse me, 6.6 frames and machines. Okay?